Hello friends, today's topic is dialysis. So, dialysis is the process of separating molecules in solution by the difference in their rate of diffusion through a semi-permeable membrane. So, dialysis is a process which are using to separate molecules of a solution on the basis of the difference in their rate of diffusion through a semi-permeable membrane. The most common application of the dialysis is for the removal of unwanted small molecules such as salt-reducing agent or dye from larger macromolecules like proteins, DNA or polysaccharides. So the most common or the most important application of this method is the removal of unwanted small molecules like salt-reducing agent or dye from larger molecules like proteins, DNA or polysaccharides. Dialysis is also commonly used for the buffer exchange and also in the drug binding studies. And the concept of dialysis was introduced in 1861 by a British chemist, that is the Thomas Graham, and he used this technique to separate the sucrose and gum arabic solutes in aqueous solution. So, dialysis is simply the process of separating molecules in a solution on the basis of the difference in their rate of diffusion through a semi-permeable membrane, and its most common application is in the removal of unwanted small molecules from the larger macromolecules like a proteins, DNA or polysaccharide, and it is mainly used for the buffer exchange and drug binding studies, and this concept was introduced in 1861 by the British chemist Thomas Graham, and he used this technique to separate sucrose, that is a small molecule, and gum arabic solutes, that is a large molecule, in aqueous solution. This is a diagrammatic representation of the dialysis. Then coming to the principle of dialysis, diffusion is a random thermal movement of molecules in a solution that lead to the net movement of molecules from an area of higher concentration to a lower concentration until the equilibrium is reached. So, diffusion is the process of the net movement of molecules from an area of higher concentration to the lower concentration area until an equilibrium is reached. And in dialysis, a simple and a buffer solution are separated by semi-permeable membrane that will cause a differential diffusion pattern and thereby permitting the separation of the molecules in both the samples and the dialysate. So in coming to the dialysis, a sample and a buffer solution, and the buffer solution is known as the dialysate, and are both are separated by a semi-permeable membrane which will cause the differential diffusion pattern and thereby permitting the separation of the molecules in the sample and the dialysate. And due to the pore size of the membrane, large molecules in the sample cannot pass through the membrane and thereby restricting their diffusion from the sample chamber. So due to the pore size of the membrane, the large molecules which are present in the sample we are analyzing cannot pass through the membrane, and therefore they are restricted and their diffusion from the sample chamber and can be easily separated. By contrast, the small molecules will freely diffuse across the membrane and obtain an equilibrium across the entire solution volume, thereby changing the overall concentration of these molecules in the sample and the dialysate. And the dialysis can be used to either introduce or remove small molecules from a sample, because small molecules will move freely across the membrane in both the directions, and this makes the dialysis a useful technique for a variety of application. And it is a process used to change the matrix of molecules in a sample by differentiating molecules by the classification of size. So here the small molecules will freely diffuse across the membrane and will obtain an equilibrium across the entire solution volume, and thereby changing the overall concentration of these molecules in the sample and dialysate. and it can be used to either to introduce or remove small molecules from a sample, or because small molecules will move freely across the membrane in both direction, and this will make the dialysis a useful technique for a variety of application, and is the process used to change the matrix of molecules in a sample by differentiating molecules by the classification of size. Then coming to the types of dialysis, first one is the diffusion dialysis. It is a spontaneous separation process where the driving force which produces the separation is the concentration gradient. So in diffusion dialysis, the driving force which produces a separation is the concentration gradient, and the diffusion dialysis uses anion exchange membranes or the cation exchange membranes depending on the compound which we have to separate, and it will allow the passage of the anions while it will obstruct the passage of the cations due to the co-ion rejection and the preservation of the electrical neutrality, and the opposite will happens with the cation exchange membranes. In diffusion dialysis, here the separation process occurs where the driving forces which produces this separation is the concentration gradient, and in this diffusion dialysis uses either anion exchange membrane or the cation exchange membrane depending on the compound we have to separate, and this anion exchange membrane allow the passage of the anions only while it obstruct the passage of the cations due to the co-ion rejection and the preservation of the electrical neutrality, and this the opposite will happens when we are using the cation exchange membranes. Second type is the electrodialysis. Electrodialysis is a process of separation which uses ion exchange membrane and an electrical potential as a driving force. It is mainly used to remove the ions from aqueous solutions. There are three electrodialysis processes which are commonly used, that are Dunning dialysis, reverse electrodialysis, and the electrodialysis. So in electrodialysis is the process of separation which uses ion exchange membranes and an electrical potential as a driving source, and it is mainly used to remove ions from aqueous solutions, and mainly three types, that is the Donnan dialysis, reverse electrodialysis, and the electrodialysis. Okay, then what is this Dunning dialysis? It is a separation process which is used to exchange ions between two aqueous solutions which are separated by either cation exchange membrane or an anion exchange membrane. So it is a separation process which is used to exchange ions between two aqueous solutions which are separated by either cation exchange membrane or an anion exchange membrane. And the second one is the reverse electrodialysis, and it is a technology based on the membranes which gets electricity from a mixing of the two water streams with the different salinities, and it is a technology based on membranes which gets electricity after mixing of two water streams having different salinities. And the third one is the electrodialysis, and it is an electromembrane process with three compartments which combines electrodialysis and electrolysis, and it is commonly used to recover acids from solution using anion exchange membrane, cation exchange membrane, and electrolysis, and the three compartments are separated by two barriers which are the ion exchange membranes. Coming to the applications of the dialysis, dialysis has a wide range of applications, and it can be divided into two categories depending on the type of dialysis used. First one is the diffusion dialysis, and its applications are in strong aqueous caustic soda solutions can be purified of hemicellulose by diffusion dialysis, and the acids can be recovered from the aqueous solutions using this method, that is using the anion exchange membranes, and the alkali waste can be recovered using diffusion dialysis because of its low energy cost, and the dealkalization of beer is another application of the diffusion dialysis. Coming to the second one, that is the electrodialysis. Some applications of the electrodialysis are the desalination of whey is the largest area of use for this type of dialysis in food industry, and the deacidification of the fruit juice like a grape, orange, apple and lemon are processes in which the electrodialysis is applied, and it is also used in the desalting of soy, so separation of amino acids into acidic, basic and neutral groups. Coming to the advantages and disadvantages, first we will see about the diffusion dialysis. The main advantage of this method is the low energy consumption of the unit, and this membrane technique operates under normal pressure and has not a state change, and at the same time this fact diminishes also the operating cost, and moreover it must be highlighted that the low installation cost, easy operation and the stability and the reliability of the process. And the key aspect is that this diffusion dialysis does not pollute the environment. So coming to the advantages of the diffusion dialysis, the main advantages is it's a low energy consumption, and also this membrane technique operate under normal pressure and do not have any state change, and at the same time this fact will diminishes the operating cost, and it must be highlighted that the low installation cost, easy operation and the stability and the reliability of the process. And another key aspect is that this method does not pollute the environment. Or coming to the disadvantage, that is a diffusion dialyzer has a low processing capability, and also the low processing efficiency is another disadvantage of the diffusion dialysis. Coming to the electrodialysis, the main benefit of this method is its a high recovery rate, and another advantages is the fact that no high pressure is applied in this method, and also the fouling layer is not compact, which leads to the higher recovery and to a long membrane life. And the main drawback of this method is the current density limit, and another aspect to take into account is that although low energy is required to operate, the higher the salt feed concentration is, the higher the energy needed. And the electrodialysis does not remove microorganisms and organic contaminants, therefore a post treatment is usually required.